Now see this 11th question, children. A traveling microscope is used to determine the refractive index of a glass slab. So if 40 divisions are there in 1 centimeter on main scale, so that is 40 divisions are there on 1 centimeter of the main scale, that is 40 main scale divisions will be is equal to 1 centimeter. So 1 main scale division will be is equal to 1 by 40 centimeter. Next, 50 vernier scale divisions are equal to 49 main scale divisions, they are saying. So from this, 1 vernier scale division is equal to 49 by 50 MSD, but here we know that 1 MSD is nothing but 1 by 40. So 49 by 50 into 1 by 40 centimeters is 1 vernier scale division value. Now they are asking least count. So 1 MSD minus 1 VSD, so which is equal to 1 by 40 minus 1 by 40 into 49 by 50. So here if you take 1 by 40 common, 1 minus 49 by 50 will get, so 1 by 40 into 50 minus 49 divided by 50, so it is 1 by 2000. Okay, further if you simplify this, so you will be getting 1 divided by 2000 means 0.5 into 10 power minus 3 centimeter you will get, but see the option, it is given in meters, that to 10 power minus 6. So 0.5 into 10 power minus 5 meter will get. Further if you simplify, we will get 5 into 10 power minus 6 meter. So option is D. Next question. See this, the dimensions of mutual inductance they are asking. Dimensions of mutual inductance. So we will see first. Mutual inductance E is equal to minus M into di by dt is the formula. So from this, M is equal to minus E divided by di by dt. Okay, so M is equal to E W by Q we can write, and divided by di by dt we are having. So further if you write, we'll get the dimensions as ml square t power minus 2 divided by a t divided by a t power minus 1. So further if you simplify this, you will be getting the dimensions as m l square t power minus 2 a power minus 2. So that is the dimensions of mutual inductance. Now see the next question, children. If z is equal to a square b cube divided by c power 4, then the relative error in z. Okay, very simple question they asked here. So delta z by z will be is equal to 2 into delta a by a plus 3 into delta b by b plus 4 into delta c by c. Very simple question this time they ask in JEE Main 2022. Next question. If z is equal to a square x cube and y power 1 by 2, where a is a constant, if percentage error in the measurement of x and y are 4% and 12% respectively, then the percentage error in z value. Okay, this is similar to that of previous question. So here a is a constant, no, so no need to worry about that. So here 3 into delta x by x plus 1 by 2 into delta y by y. So 3 into 4 plus 1 by 2 into 12. So they already given the delta x by x values. So 12 plus 6, nothing but 18. Okay, now see the next question. Identify the pair of physical quantities which have the different dimensions. So here, if you observe carefully, specific heat and latent heat are the physical quantities that are having the different dimensions. Remaining all the physical quantities will be having the same dimensions. But coming to this option D, specific heat capacity and latent heat, So why they given this option means, see, specific heat capacity, it is nothing but Q divided by M into delta T. Okay, what is the unit? Joule. Okay, mass, kg, degree Celsius or Kelvin, whatever it may be. Okay, but if you see latent heat, it is Q divided by M, that is joule per kg. Okay, see the difference here, temperature is not there, so that is the reason why these two physical quantities will not be having the same dimensions. Next, identify the pair of physical quantities that are having the same dimensions. Now they are asking us to find out the same. Here the option given is velocity gradient and as well as decay constant. Decay constant and velocity gradient. Velocity gradient means it is dv by dx. Okay, so its dimensions will be 1 by s. Similarly, decay constant, it is nothing but 1 by s, its dimensions is also 1 by s. So the dimensions of decay constant and as well as velocity gradient. So here velocity gradient, how we got 1 by s? So velocity meter per second divided by distance, the unit is meter. Meter will get cancelled, so 1 by s will get, right? Next, given below are the two statements, assertion and reason. The stretching of the spring is determined by the shear modulus. Yes, here the stretching of the string is determined by the shear modulus of the material. So why means here stretching of the string means it is nothing but changing in the shape, so therefore it is determined by shear modulus itself. And see the next one, the coil spring of copper has more tensile strength than a steel spring of same dimensions. No. Why means, so Young's modulus of copper is less when compared with Young's modulus of steel. So here they are in the reason they given the statement completely in a reverse. Okay, the coil spring of copper has more tensile strength, they are saying no. So steel is having more tensile stress when compared with copper. So we are going with option B. Next, the area of the rectangular field is given by length and breadth given, and now they are asking us to find out for the significant figures. See here, for these types of numericals actually no need to solve at all. Why means area, after finding out the area, so you should be getting the significant, the number of significant figures in the answer should be 2 minimum. So here 55.3 is the length and the breadth is 25. So in the final answer the number of significant should be minimum of the two values, length and breadth, which we taken. So here 2 significant figures, here 3. So even in the answer also we should be getting 2 significant figures. So first of all, length area is equal to L into B. So area is equal to, so 55.3 into 25. If you solve, you will be getting it as 1382.5. Okay, 138.82.5. So but here we should round up this one to 2 significant figures. So 13.82 into 10 power 138. Okay, 2, we can do it. So it is written as 14, sorry, 1 minute. (138) 1382.5 we are getting. Now if you simplify this, so you will be getting it as 14 into 10 square directly. Why means after rounding of the significant figures we will be getting 14, and the remaining digits we can neglect, only 2 significant figures, and this 10 power 2 is not at all significant, so we can neglect that. Even in the final answer also only 2 significant figures. Actually no need to do these types of numericals. Now see the next question, plane angle and solid angle have, you know, they are having units but no dimensions. Plane angle radian, solid angle steradian. Those are the units, but these physical quantities will not be having any dimensions. See the next. So the dimensions of m, l, t power minus 2 and a power minus 2. Okay, these are the dimensions for what? Magnetic permeability. Okay, you once cross check. Next, see this match the following. Capacitance they are asking, and permittivity of free space epsilon naught, permeability mu naught, and electric field. Okay, so if you know the formulas, children, then easily you can write the units for those formulas and you can derive the dimensions. For example, so I will show you once. Capacitance. Okay, so capacitance C is equal to Q by V, right? So Q ampere into second, that is A into T, and V, so we can write it as ml square T power minus 2. Okay, and capacitance. So if you observe carefully, Q, so that is m power minus 1 and L power minus 2, and here whole square will be there, and next T power minus 2, if it comes to numerator it will be plus 2 already, so T square is there, so T power 4 will be there, and coming to ampere A square. So see, capacitance here option 3 they given, so m power minus 1, L power minus 2, T power 4, A square, like that. Okay, and next if you want you can go even with that epsilon naught also, epsilon naught calculation also you can do. Okay, if you know the epsilon naught dimensions, then easily you can find out the dimensions of mu naught, permeability of free space. Like, okay, I will give you an example. So F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, right? And from this epsilon naught will be, so Q1 Q2 divided by F into R square. Okay, so that is Coulomb square divided by Newton meter square. So if you substitute just the dimensions of all these things, so you will get the dimensions for epsilon naught. Similarly, for mu naught, so for mu naught we can go with a different type of formula, like speed of light we know it is square root of mu naught into epsilon naught. So now squaring on both sides, c square is equal to 1 by mu naught epsilon naught, and mu naught is equal to 1 by c square into epsilon naught. Here we will get the dimensions for epsilon naught now, so you can substitute here. C is nothing but speed of light, so meter square per second square. So simply you will be getting the dimensions even for mu naught also. Okay, electric field, very simple. Electric field F by Q. Okay, F by Q. F is force. Okay, L T power minus 2. Okay, Q. Okay, we can write even this one as AT, right? So automatically you will get the formula for the dimensions of electric field also, like M L T power minus 3 A power minus 1, right? Okay children, now see this question number 22. A stone of mass 20 gram is projected from a rubber catapult of length 0.1 meter and area 10 power minus 6 meter square, stretched by an amount 0.04 meter. The velocity of the projected stone is. So here we will be using the formula of conservation of energy, children. Okay, that is half mv square, kinetic energy. So it is the potential energy stored in the catapult, half kx square. So but here, so in the place of k, we can write it as half ya by L into x square. Okay, so y is Young's modulus of mv square. Both the sides 1 by 2 will get cancelled. So mass is given 20 gram as, so 20 gram, that means 20 into 10 power minus 3 kg into v square is equal to Young's modulus given 0.5 into 10 power 9 and area of cross section 10 power minus 6, so divided by L, length how much, 0.1 into x stretched by an amount of 0.04 given, so that is 0.04 whole square. So if you simplify this, so you will be getting the value of v square as 400, so v will be 20 meter per second. See the next, if in 5 complete rotations of a circular scale, the distance traveled by the main scale of the screw gauge is 5 mm. So actually what we'll do to calculate the pitch of the screw, distance moved 5 mm divided by number of rotations given, that is pitch is 1 mm. So now least count if you try to calculate from this, so it is pitch divided by number of head scale divisions. So pitch is 1 mm and the number of head scale divisions they given 50. So we will be getting this one as 0.02 mm. In centimeter it will be 0.002 centimeter, but see here they given the least count as 0.001, but according to the given data the least count should be 0.002. that is, assertion is not correct. But if you see the formula for the least count, pitch divided by total number of divisions on circular scale, it is correct. So reason is correct but assertion is wrong. Now see the next question, number 24. So 2 wires of same length and radius are joined end to end and loaded. So the Young's moduli of the materials of the 2 wires are y1 and y2. The combination behaves as a single wire, then its Young's modulus is, see children, end to end connected. Okay, so in that end to end connection, so we can call it as series combination. So in this series combination, delta L will be is equal to L1 plus L2. We know the formula for the Young's modulus, y is equal to, so f into L divided by a into delta L. So from this, what is delta L? So f into L divided by y into a. This is the formula for delta L. Okay, but here they said that 2 wires, materials of the 2 wires behaves as a single wire, same length and radius. Length is same and even radius is also same. So that means as the lengths are same and the radius is also same, and even the loads that are connected to them also same. Okay, loaded, same load they connected. So in that particular case, children, delta L is proportional to L by Y. Okay, and that too, that is delta L is proportional to L by Y, and the equivalent length they given it as 2L. Equivalent length, Y means end to end connection, no? So total length will be 2L. So according to the formula, delta L is equal to delta L1 plus delta L2. So delta L means we can write it as L equivalent divided by Y equivalent, which is equal to L divided by Y1 plus L divided by Y2. Okay, so substituting the values, 2L divided by Y equivalent, we will write it as Y. L divided by Y1 plus L divided by Y2. So here both the sides L will get cancelled. 2 by Y is equal to, so Y1 Y2 divided by, sorry, it will be Y1 plus Y2 divided by Y1 Y2. So if you simplify this, Y will be 2 Y1 Y2 divided by y1 plus y2. By cross multiplying we will get this. Option C. Now question number 25. Here the area of cross section of a railway track is given and the temperature variation is 10 degree. The coefficient of linear expansion of the material of the track is 10 power minus 5, that is alpha value given. The energy stored per meter, so in the track, energy stored, okay, so energy is equal to, so we can write this formula as energy stored per meter they are asking. Okay, so actually energy stored per volume, it will be is equal to half into stress into strain, but we can write this one as half into strain square into y. Okay, but here they are asking energy per unit per meter, no? So we'll bring that volume that side. So energy is equal to half into strain square into y into volume, that is half into strain square into y into volume, we can write it as area into length. Now again you bring this length this side, so energy per meter will get, so half into strain square into y into a. But again you know that strain is nothing but delta L by L. Again here they given the coefficient of linear expansion, that means, so you know the formula even for that also, alpha is equal to delta L by L into delta T. So from this alpha into delta T will be is equal to delta L by L. That means children, in the place of strain here we can write alpha into delta T, that is 1 by 2 into alpha into delta T into y into a. So that is equal to 1 by 2 alpha value 10 power minus 5 given, and temperature 10, y value how much, Young's modulus 10 power 11 they given, into area of cross section 0.01. So if you simplify this, you will be getting this one as 5 joule per meter. Option B. Okay, now see the next question, children. A screw gauge gives the following readings when used to measure the diameter of a wire. So main scale reading 0, that is pitch scale reading 0, and head scale reading is 52, and here 1 mm of the main scale corresponds to 100 divisions, that is least count 1 by 100, that is 0.01 in centimeter, it is 0.001 centimeters. So now radius they are asking, so total reading per formula we know, that is PSR plus HSR into LC, so that is 0 plus 52 into 0.001, so it will be 0.052. Okay, option D. Now see the next question. A uniform metal wire is elongated by 0.04 meter when subjected to a linear force F. The elongation, if its length and diameter are doubled and subjected to the same force. Okay, so that means elongation, length and diameter they are asking, children, remaining everything is same, subjected to the same force. That means, so according to the formula, F is equal to YA into delta L by L. So from this, delta L is equal to F into L divided by Y into A, right? So from this relation, so we can say that delta L is proportional to L by R square. Y means area is nothing but pi R square, no? Delta L is proportional to L by R square. So here what they are doing, if the length and diameter are doubled, okay, length they are doubling and even diameter also they are doubling. So that is delta L1 divided by delta L2 will be is equal to L1 by L2 into R2 by R1 whole square will get. So after substituting the values, so we will be getting the elongation as L2 is equal to delta L1 divided by 2, but delta L1 is already given in the question as 0.04. we will substitute, so we will get it as 0.02 meter. Okay, 0.02 meter, but see option they are asking in centimeters, so that is delta L2 is equal to 2 centimeters. That is option 2. Now see the next question. Then a normal density of a material is rho and its bulk modulus of elasticity is k. The magnitude of increase in the density of the material when the pressure P is applied uniformly on all sides. Okay, we know that density basic formula, mass by volume. So now if you differentiate, so d rho by rho, we will get it as minus dV by V. Why? Here they are saying that the magnitude of increase in the density of the material, they are asking when the pressure P is applied uniformly in all the sides. Mass will not be changing, children, that is the reason why. So mass we neglected there, we just taking the proportionality. So what are the things that are going to change? So density and volume. Here negative sign indicates that it is decrease, but we know that the bulk modulus K is equal to minus P divided by dV by V, right? From this minus dV by V is equal to P by K, right? So can we substitute this P by K value here? So that is d rho by rho will be is equal to P by K, and from this d rho will be rho into P divided by K. So rho into P divided by K. Next, see, if y, k and eta are the value of Young's modulus, bulk modulus and modulus of rigidity of any material respectively, then choose the correct relation of these parameters. So here first of all we will see the relation between Young's modulus and bulk modulus. So that is y is equal to, so 3k into 1 minus 2 sigma. Here sigma is Poisson's ratio, children. So from this y by 3k is equal to 1 minus 2 sigma, right? So y divided by 3k, we will bring this y divided by 3k this side, so it will be 1 minus y divided by 3k, 2 sigma value. So sigma is equal to 1 by 2 into 1 minus y divided by 3k. And next one more relation, y is equal to 2 eta into 1 plus sigma. So here this is the relation between Young's modulus and rigidity modulus eta, and here sigma is Poisson's ratio. Again from this we will get sigma as y divided by 2 eta minus 1. So let us take this one as equation 1 and equation 2. Both the equations are giving sigma, no? So if we equate these two equations, so 1 by 2 into 1 minus y divided by 3k is equal to y by 2 eta minus 1. So we will simplify this. Okay, y divided by 3k is equal to 3 minus y by eta. So y divided by 3k is equal to 3 eta minus y divided by eta, and eta, if you bring this side, eta into y divided by 3k is equal to 3 eta minus y. Okay, they are asking k value, no? Just do the cross multiplication. So you will be getting eta y divided by, so 9 eta minus 3y, 9 eta minus 3y. Okay, here see children, if you send this to that side, so we will be getting the equation as here, if you are not clear with this, you can write like this: 1 minus y by 3k is equal to, so y by eta minus 2. That means if you are taking this to this side, so here 2 will get cancelled, minus 2 into 1 2 will get this one. After simplifying this equation, we will get this, right? Now see the next question. Two separate wires A and B are stretched 2 millimeter and 4 millimeter respectively. Okay. When they are subjected to a force of 2 Newton, both are subjected to the same force. Assume that both the wires are made up of the same material and the radius of the wire B is 4 times that of the radius of wire A. Then the length of the wires A and B are in the ratio A is to B. Then A by B can be expressed as 1 by X. Then what is the X value that they are asking? So now for material A we will write. So F by A is equal to Y into delta L by L. Okay. That is, so Y into 2 millimeter they given and length given is A. And for wire B, so F divided by, here we can write it as pi r square also. Okay, F divided by A is equal to Y into 4 mm divided by B. Okay children. Okay, but here we can write this equation like this: Y into 2 mm divided by A is equal to F divided by pi r square. Even we can write Y into 4 mm divided by B is equal to F divided by pi into, here see radius, the radius of the B is 4 times on the, so they said, so that is 16 r square it will be. So this is equation 1 and this is equation 2. So if you take the ratio or divide equation 1 by 2, y will get cancelled, f will get cancelled, pi will get cancelled, and r square also will get cancelled. So here 2 times. Okay, what will get? 2b by 4a is equal to 16. So that means a by b will be is equal to 1 divided by 32. Okay, 1 divided by 32. Here they said that it is a by b value is 1 by x. So now what you are observing in the place of x here? 32.